Welcome once again to my YouTube channel. Today we continue on with engineering mathematics made easy. So today we are going to a new topic which is called binomial expansion. For binomial expansion, this is what we have. We have the definition there where we are talking about what is binomial, and then we also talk about binomial expansion, where we say it's when we raise a binomial, like for example a plus b raised to n, then we use binomial expansion. So the first thing we look at before we go to binomial expansion is what we call a Pascal triangle. This is a Pascal triangle and it is written like this. You can write one, then you write another one there, and another one. That's how you start it. Then you can say 1 plus 1, you get 2, then you write 1, then you write another one there, 1 plus 2 3, then 2 plus 1 3, and then you write another one like that. You continue on 1 plus 3 4, like that, 3 plus 3 6, 3 plus 1 4, and then you get 1. So this one we call it a Pascal triangle, and this can continue on and on like that. And so we come to, I have described that, then we can come to an example where we can use the Pascal triangle. First of all, Pascal triangle is used. These are supposed to be the coefficient of binomial expansion. So for example, let's use this one. This is used for, we can use it for this. We can use it for expanding 1, that is not 1 but x plus a half raised to 4. So we use this to expand that. These are the coefficient. So this one will be equal to, maybe I can put this one aside so that we can use now this. So this one will be x raised to 4. Then we have a half raised to 0. Our first coefficient is 1. So when we continue for binomial expansion, this x will go on descending order. It will be raised in descending order, while this one will go on ascending order. So the next one, we'll put 4 there, x raised to 3, and this half will be raised to 1. Then plus, then we have to 6, this 6, x raised to 2, then half raised to 2. And you can even note 4 plus 0 is 4, 3 plus 1 is 4, 2 plus 2 is 4. So make sure always the powers that raises these values should give us 4. So the next one will have 4, x raised to 1, then a half raised to 3. And finally, we have 1, x raised to 0, 1 over 2 raised to 4. So this one gives us, finally, you'll have x plus a half raised to 4. This one will be equal to, for this one is 1, so we'll have x raised to 4 plus, we have, this is going to be 2x cubed, while this other one is going to be 3 over 2, because this is 2 times 2, that is 4. 6 divided by 4 is 3 over 2, x squared, plus, for this one, this is going to be a half. 2 times 2 times 2 is 8. 4 divided by 8 is a half, x raised to 1, and then finally plus 1 over 16. So this is what we are looking for. You can compare this and that. So that is what we were looking for. And so that's how we can expand that. Now we come to binomial theorem definition. But before we go to that, there is something called combination. You have combination 4 and 0. This one gives us 4 factorial all over 0, 4 minus 0 factorial. So this one will give us 4 multiplied by 3 times 2 times 1 all over, that is 0. 4 minus 0 is 4. So it will be 4 times 3 times 2 times 1. So this one will be equal to 1. If let's say you are given like C, that is combination 4, and here we have 1. So this one is going to give us 4 factorial all over 1 factorial, 4 minus 1 factorial, like that. This one will be 4 times 3 times 2 times 1 all over 1 factorial. This one will be, this is 3, so it is 3 times 2 times 1. You can cancel that one. So finally we'll end up with 4. So if this was n, if it was c n 0 there, this one is going to be, the first one will be 1, and the second one, if you have n there and 1, this is going to be n, like that. So the combination is used in binomial expansion, and we shall see it later as we continue. So guys, let's expand a plus b raised to n. This is equals to, this combination, this one can be written as n like this. It can be written like this. This other one can be written as n and 1 like that. So this is the combination we are talking about. This is the combination. And for this one, if you can expand maybe to a certain value, for example, we start n0 like that. Then we come and write a. We write here is n, and then b we write is 0. A will go on descending order, while b will be on ascending order up to n. So this one will be plus. Then we write n1 like that. A raised to n minus 1, b raised to 1. And finally we can write the last one, n, and that here we have 2, a raised to n minus 2, b raised to 2. So this one will be a plus b raised to n will give us, the first one will be a raised to n, and that is this here. It will be, you have 1 there, but you don't have to write the 1, plus, because b raised to 0 is 1. So this one will be, it will be n, a raised to negative, a raised to n minus 1, b raised to 1, plus this other one will be n minus 1 all over 2 factorial, a raised to n minus 2, b squared. And this is what we get when we compare, this. If you can compare this, these two, you can see what we are getting, something that looks like that. It's only that we did not go up to n, that is to 3 factorial 3. We reached up to factorial 2, and so it's written like that. This is the general binomial expansion, binomial expansion. So this one is used for all integers, unlike the Pascal triangle where we just use the positive integers without fractions. So let's go to another example. Expand 1 over square root of 1 plus x as power series. So let's see how we can expand that using our general binomial expansion. So this one we write it like this. Here it will be 1 all over square root 1 plus x. This one is equals to 1 over 1 plus x raised to negative, not negative, but raised to a half. So this one will give us, if you bring it upward, it will be 1 plus x raised to negative a half. And so this is what we are now expanding. How do we expand it? We come here and write 1 plus x negative a half is equals to, here we shall have 1, because 1 raised to negative a half will still be 1. And then we'll have x here raised to 0, which will still be 1. So we can do away with that. So we'll have 1 plus negative a half, like that. Then we write x raised to 1 plus, then we have negative a half, then negative 3 all over 2. We have the 2 factorial there, and x raised to 2. Remember, x is in ascending order, while the 1, if it were there, it would be in descending order. Then from there we come to plus negative a half, then we have negative 3 over 2, then we have negative 3 over 2 minus 1, it is negative 5 over 2, all over 3 factorial x cubed, like that. So finally, we shall have something like this. This one will be 1, our answer will be 1. This one will be minus, then we have a half x raised to 1. For this one, you have positive. You have 8 there, that is 2 times 2 times 2, 8. Then you have 3, x squared. Then you have minus, because of the minuses are odd numbers. So when you multiply them, you get a minus. Then this, you'll get, if you multiply that one, you get 5. All over, this one will be 2 times 2 times 2 times 2, will be 16 x cubed. And you can compare that answer with whatever has been given here, which is this. This is now the answer you are supposed to get. This is our answer. And then that is our answer. And then we still have another question here, which says, use part A to estimate that. Correct to 3 decimal places. To estimate 1 all over square root of 1.1, that is 1.1. So this is how we have expanded our value, and then we want to get 1 over square root of 1.1, like that. So for this one, we will say, because our initial value, the expansion for this one was from 1 over square root of 1 plus x. So this should be equal to this. So let's look at find x. It will be 1.1 is equals to 1 plus x. So x is equals to 1.1 minus 1. Then this one gives us 0. That is, if you take away 1, it will be 0.1 is equals to x. And so this is what we are going to put into our equation there. This is our equation, we put 0.1. So let's put 0.1 into our equation there. So this one will be 1 minus a half, we put 0.1 plus 3 over 8, put 0.1 minus 5 over 16. This one will put 0.1 there. Then we can now calculate this. So this one will be 1 minus, if I use the calculator, you'll get, that is 0.1 divided by 2 is equals to, this one will be 0.05, like that. This other one will be, this will be now 0.001 times 3 is equals to that, divided by 8 equals to that. That is 0.00. This will give us 0.000375, like that. And that is it's correct. Finally, minus, we have this figure, we calculate that one, it will be, you'll have 0.001, like that, for this one. Then you multiply by 5 equals to, you can divide by 16. This will give us, I can see that figure. This one will be 0.000, then we have 3125. 3125. Then we can add these values and you will get 1 minus 0.05 plus 0.00375 minus 0.000, that 125, that 125, this will give us equals to 0.953. This one will be 0.9534. Then you are told to do it to 3 decimal places. So this one will be 0.953. So this is going to be our answer. So guys, that's how we do that problem. We get as shown, our answer as shown. So thank you. See you in the next lesson. Bye bye.